So, we will again use Python for parallel programming now. Okay. So, last class we worked with multiprocessing module. So, we could create more process and those process could do things in parallel, right. So, there is a related module called multi-threading. It will create more threads, okay. And we have discussed the difference between threads and process. So, this will also speed up the code. Okay. This is more this similar to OpenMP. So, what we do in OpenMP in C++, Fortran, C, this is basically multi-threading OpenMP. So, in Python some functions, we write a function which can be executed by many processes, by many threads. So, if you divide the data and this function will act on different parts of the data, the way I discussed for multiprocessing. So, instead of process it is going to be threads. So, now let us just recap the difference between process and thread. Okay. So, process, so we can create a process. In fact, in a computer, in a laptop, there are many processes are running. Somebody is doing the email, browser and so on. So, each process will run some program. So, we can create, so you want to run parallel process and you have to create this process, we did it last time. It turns out, however, the creation and annihilation of the process is expensive. So, typically multiprocess, this process will take longer time than threads. Thread is lightweight, okay, and the heavyweight means it takes longer time. Every process has their own separate memory, separate register, separate cache. So, you need I mean basically you have to arrange all this stuff. So, it takes time. However, for threads many things are shared. Okay. There are only few things which we are private, and so it is easy. You just create threads and they are, of course, it will have it will run different programs, all threads, but they share a lot of stuff. So, a process has its own memory, one process does not share memory with another. Okay. But in our code which we wrote, Python code, Python is slightly flexible. Okay. So, the main memory was shared. So, that was normally multiprocessing will not work in C, but Python makes always okay, let's do it type, so it is a very flexible. So, it was shared, memory was shared. In fact, there was a package shared memory which I used it, but then it turned out that without shared memory also things work. Okay. So, if you just create an array, it is shared. There is a package in shared in multiprocessing to shared memory module. I used it in the past, but I checked it works without that itself. But here threads share the memory. So, we do not need to do any kind of extra work. Okay, it is memory shared, and it will become clear with an example. In fact, multi-threading is simpler. The programs here are simpler, but the idea remains exactly the same, like what I did in the last class. One core typically runs one process, though we can create more process. So, by the way, you can run all these codes in a laptop. If you have Anaconda installed, you can easily install these packages. Some of it is already available. If you install Anaconda, it will be available. So, we can so, but Conda install package name. I hope you know this stuff, right. You can install new package by Conda install package name. But in Google Colab also we can easily in fact Google Colab things are there. You just import and it just works. Okay. So, one process will run, typically you want one process on one core. Sometimes they advertise that one process can do 2 threads for HPC as well, but they are not very efficient. Okay. So, in fact, the performance can worsen. So, I mean the following, some code with, let us say I have my computer has a laptop has 4 process, quad core, right. So, I run with 4 process, it will be faster than single one, definitely. It will be faster than also 2 processors. Okay. If you use more processors, it definitely get some gain, but what about I use now 6 or 8, it turns out the wall clock, the total time is more than sometimes more than what it takes for 4 processes. Okay. So, it has become worse. So, it's just overheads, I mean the one core says, well, now I have to do two things, the guy is already tired and they say, well, you are making me more tired. So, time sharing, all that stuff takes time and it does not work. Okay. So, I advise you to do one core, one process, but in it here also one core can create many threads, but I suggest that you use one core for one thread. Okay. So, HPC application we should use one thread per core, that is efficient. Okay. Now, multi-threading for shared memory, we can use multi-threads. Shall we restart this one? So, multi-threading for shared memory, so it is shared memory. Okay. So, it will work on a single node. You cannot run this multi-threading on two nodes, it will not work. So, for a single node multi-threading will work. So, it can use all the cores of the process of the node, like your laptop. It is not a node, but it can all the cores of the laptop can be used. In our computer center, we have nodes with 32 cores. So, you can use all of 32 cores. Threads can be executed in parallel, that is why we use it for parallel processing. Each thread its own counters, registers, stack, but memory is shared. Okay. So, these are inside the CPU, you recall, right, the counters, they are part of the processor. Speed up only the so advantage of multi-threading as well as multiprocessing is, if you look at the code, we had one main program and there was a function which was executed by all the processes. Same thing we will do here. So, if you have sequential code, then look at the function which, so you need to write the function separately, okay? One which is to be parallel, and that function should be executed by all threads. Okay, that is the idea. So, we will just work, I mean you will parallelize only one part of the code, that is saves time. You do not need to parallelize the whole code, you just worry about one function. MPI is different. MPI you need to think, in fact, I will show you in MPI today only that MPI function or MPI whole program runs on all the process. Okay. MPI is not for threads, MPI is for process. Okay. Now, the timeline. So, it is similar to what I did in the last class, but it is not, we create threads. So, we have the main program P0 here, then it is creating a thread T1, T1 is the thread, then it will terminate the thread, thread is destroyed here, then next thread is starting T2 terminates here, and after termination only main program survives. So, this the parent process. So, you need to have a process which will create threads. Without threads, without process you can't create threads. Okay. Now, these are non-overlapping threads, right? T1 and T2 are not overlapping. However, if I can start two threads at the same time. Well, same time means one after the other, but before terminating the earlier thread. So, I start a thread here T1, but then I can start another thread T2. Okay. This guy is doing some work right here and he is also doing some work, but once T1 finishes, it will exit here and T2 finishes, exits here. Okay. By the way, it is possible that T1 exits somewhere here, that is also possible. So, two threads or even 100 threads can coexist. Now, for parallel programming we need to use this. You create the threads, let them work, whenever the work is done is killed and all of them join, means they are killed and finally we get back to main process. Okay. So, the syntax is pretty simple. So, this is a module threading. So, there is a function called threading. So, this T is capital. Okay. So, that will create a thread T. Okay. It is assigned a task. What is the task? It has to execute the function f. So, this is called target. Target is what I need to do. So, target says, well, execute function f. and what argument I should use? Essentially it is a thread index. Okay. So, we give thread index and that is I. This is thread index. But it could be, you could have more than one argument. For example, local sum can go in there and things like that. And we start a thread by t dot start and end the thread by t dot join. Okay. So, these are the functions start end, and I will show you some more functions bit later, and this for creation. So, creation, start, end. By the way, this does not start the program, it is bookkeeping only. Okay. It is basically created the threads, they are ready to go. Okay. But once you start, then they will execute. Okay. So, here we are. So, this is the function, my function. It is very simple function, it is just printing the thread number and time. So, this is my main program. Okay. So, I am going to create two threads, this two. So, thread is a list, we create a list. So, then I say, well, I create the thread. So, I am in loop. So, first time it will create thread 1. So, the t is a variable, okay. This t is a variable. So, it will create a thread 1 and it is task is to produce to execute my function with argument I, which is the thread index. Then thread is appended. So, I need to keep a list. So, this thread, this t is appended in the list. So, the first entry of that list is the first thread. It is an object, okay. So, it may have some more lot of information, thread ID, then we have t start and t join. So, here the first thread has started to execute, and then we say, well, join time. So, this is already joined. So, this is the time joining for thread 1, this will be printed. Then we go to the loop again for the next thread. So, that it is going to run 2 times, no. So, I becomes 1, from 0 it becomes 1, and I do it again, but this time thread will be, thread ID will be 1. They are integers, in fact, they start from 0, 1, 2, 3 like that. Okay. So, it is, in fact, lot of this parallel processing is pretty easy. You look at it, I mean, if you know how to do a sequential program, you just can write the parallel program easily. Just need to divide the data and assign to particular threads. So, the next thread starts and it goes from here and it goes there and like that. Okay. So, since I am talking about it, let me tell you my story about parallel programming. I started quite late, I was not doing parallel programming. So, in 2003 I met my Belgian friend. So, I said, well, how complicated is MPI of parallel programming? He said, well, very easy, you just need to know 5 functions. He said, send, receive, these are the 2 main functions, reduce. So, basically you just need to focus on 5 generic functions. Here I said start end, and there was one more thing will come. So, it is pretty simple, parallel programming is not difficult, just need to divide the data and think parallel, that is what you need to do, you have to think parallel. Syntax is very easy. So, these are the new functions and we need to learn these functions. Now, this is very similar code, but except what I have done, I have taken the join outside. Join is not of the first loop, join is happening in the second loop. So, first loop is creating thread, appending in that list and start. So, T1 starts here and T2 starts here, but they started, but now we need to end it. Okay. So, we say, well, T dot join. So, join means this here, and join, once you join the main process, then your life is over. And then I print the join time, and so both of them in a loop. So, first one, second one. By the way, when you say T dot join, it will join only when the task is done. When you say T dot join, does not mean that I am going to join. It says, well, we are done, you join here. And in this loop, the first one will join Okay. So, in the T thread, sorry, they did not join simultaneously, or T1 can join first, T2 join later, or T2 join first, T2. So, there is no priority that T1 should join first, T2 join later. You can make the job of T1 heavier, then you find that T1 will join later. Okay. So, it is simple. So, thread is basically a worker, and that will do the parallel programming. Okay. Now, we need to know something called lock. Now, why lock is important? So, imagine I have big array and I divide in 4 threads into 4, divide the data in 4 parts, and they are to be, I need the sum of the array elements. So, I need partial sums for each block, 4 process, 4 partial sums, and then somebody has to add these together. So, we have local sum, this is a variable I have been using. So, local sum, 4 of them, right, local sum, but then we add all of them together, sum. But you might, so the sum is a single variable. Okay. In fact, remember there is only one program running. I create threads, they will generate local sums. Now, so imagine the thread 0 adds to sum, at the same time thread 1 comes and says, well, I also want to add. Now, these two guys come and they can basically screw up the variable sum, right. They should do one after the other. You can't, there is a register where to enter, but 2 people simultaneously can't enter. So, one after the other. So, you say, well, when I am, so when the first guy is doing the writing on local sum, this is the lock. So, first guy says, I am going to lock the room, I do my work and open the lock, only then next guy should come. Is it clear? So, the variable is not disturbed, or simultaneously people do not, 2 people do not want to try. If a variable 2 people want to write together, it is possible. One of them will basically, one number will not be added at all. Computer, well, there is no, computer is basically a machine. If there is a conflict, it does not know how to resolve it. Okay. So, it has to be told that okay, lock the room. When thread comes, thread can get the key, lock the room from inside, work, and then open the door, then next guy will come. So, that is the idea of lock. So, so this is some syntax. So, thread lock is a variable. So, threading dot lock. So, basically it gives you a variable where, which is like a key in some sense. So, you acquire the key, thread lock dot acquire. So, any thread can acquire the lock or the key rather, then that guy will do the sum, means add that local sum to sum, and then release the lock. Okay. So, this is how you resolve several threads trying to acquire, trying to write onto same variable or manipulate a variable, which is a common variable. Sum is a common variable. Okay. I mean, we need a single sum, we do not want too many sums. Okay. And this is called race condition. So, 2 people are trying to racing to work on the same data.